So, hello and welcome to our next talk. Right before you is Wiktor Mazur from Techland. Wiktor works as a senior technology programmer there, and in his talk he will walk you through the way of how game dev production evolves from being able to produce simple, relatively small games to multiple AAA products. So, the stage is yours.
Thank you very much. So, hello, everyone. Today, I want to tell you a story about the bakery and how we managed to cook 2 games in one stove. And some of you probably may wonder what the hell is going on with this title. Fortunately, today I'm going to unveil the secret and tell you that the bakery is a simply sweet name for the Techland, so the company I'm working for. The 2 games that I'm going to talk about, one of them you may be familiar with, it's a Dying Light 2, and the second is our unannounced title that we are working on. And of course, the stove will be the technology that we use to build those 2 games. Yeah, that's me. And few things about me, because, well, my background isn't so obvious for the game development. So before the game dev, I was working at Nokia. I was working about 5 years there, and I started there as a working student, then became a software developer, and, well, ended up as a technical leader. While in there, I was working on the BTSs. So BTS is basically some box connected to the antenna thingy somewhere in the road, just simply allowed you to make your phone calls. So 3 large projects all around the BTSs. One of them, web development application in JavaScript. Second, the embedded software for these BTSs, for which I wrote tons of C++ code and did a lot of reviews. And another, the testing software for the BTSs. So we could, well, test it without the need of uploading it to the target hardware. So it was nice, but, well, it was kind of boring, so I decided to switch my career, and I started to work at Techland. Well, it was like about 3 years ago when I started as a QA engineer. While in there, I was working in the GameBot technology and automation software. And when it became stable, useful for the QAs, I changed my career a little bit, and I became a senior technology programmer, working in the CI/CD build system, web application, and tools environment. And today my talk will be focused around those topics. And a little disclaimer, since I'm in Techland only a little more than 3 years, I wasn't taking an active part of the development of the most software that I'm going to talk about. But as a member of the DevOps team, I have an opportunity to work on this stuff on my daily basis. And right now, I would like you to hold up to your questions, because, well, probably most of it will be solved during my talk. Yeah. So for the agenda, when we are going to talk about making 2 games at one time, I want to divide it into 3 main parts. One of it will be the coordination of lots of people that are working together. That's, you know, that in game development, beside the programmers, we have a lot of people like the quest designer, writers, artists, QAs, many people. So the first part will be focused about the processes and workflows that we use to build those 2 games. Second one, the management of the large code base. So, which was kind of inevitable when we decided to work on those 2 games in the way that we did. You will see. So this part will be about the CI/CD. And the third part, lastly, I'm going to talk about the fault management and how we embrace the changes that one game made to another. So, the coordination. The classic software approach that I really used to while working in commercial software at Nokia is, well, kind of simple. You're going to divide your system into some functional blocks, then establish an APIs between them. After that, you're going to assign them for the development teams to work on them, and release them on some schedule, right? Simple, we know that. it has a lot of advantages, like your features are probably going to be stable since you have scheduled releases, you have time for careful integration, testing. Also, it's going to be reusable, right? Because you specified some boundaries, you divided your system into some blocks. You probably can use it in other game, other part of your system, future projects. And lastly, the quality of the code. Since you have time for integration, you probably have time for writing some integration tests, right? So in the end, it gives you a lot of confidence for changing your code. But, of course, it has some disadvantages, right? Like everything in life, neither also the game development, it's not a silver bullet. For first, your code needs to be independent. And you know that in game development, we have a lot of components that are highly interconnected with each other. We have the physics, audio, animations, you know, the drill. And lastly, this is my thought from working in Techland, is that the code and the assets always needs to be verified as a whole. I mean, the game needs to be verified as a whole. Basically, you need to play the game to verify if the look and feel is still there. You cannot simply write some set of tests and decide by that it's correct, it's still working. You need to test, you need to play the game. And right now, I would like to tell you about our technology stack, well, at least a part of it. For first, we are using the C engine, is our custom engine. And from what I know, we are only company in Poland that are still using the custom engine for making the AAA games. And for the content management system, for the versioning of our files, we are using the Helix Perforce. And right now, I would like to ask you if you are personally using the Helix Perforce in your daily basis work. Can you raise a hand up? Okay, I see there is one person who are using Helix Perforce. All right, so I will tell you why we are using it in Techland. So basically, first, there is a support for large files. You know that in game development, we have the assets, which, well, they can get quite big, right? So the support for storing them in the repository allows us to store the code together with the assets. Seconds are the streams, which are basically branches with brains, like the Helix Perforce like to call them. There are the way that you can specify relationships between the parent branch and the child branch. For example, you can have a parent stream and a child stream, and in the child stream, you're going to use only the subset of files that are used in the parent stream. So this will be useful later when I show you the repository and, well, the structure of our repository that we're using. And lastly, the merge down, copy up integration part. It basically looks like that. You have the parent stream and the child stream, and first you're going to merge down everything from the parent stream to the child stream, integrate the changes, so resolve the conflicts, etc. And after that, you're going to copy everything up. So after the integration, you're going to have exact copy of your files in both streams. And yeah, this is how it works. So the workflows before we started to work on those two games. So basically all the games before the Dying Light 2. It was quite simple, to be honest. We have one stream of changes where all our stakeholders were pushing their changes. So we have the game programmers, the engine programmers, content creators, everyone who are pushing their changes there. And, well, it worked. We released all those games. But, well, there were not so many developers back then, and only one game was developed at the time. But even then, there were some issues with stability. I need to tell you that the content creators were always, and still is kind of, are using latest version of engine. So you can imagine that when the engine programmer pushed their changes that simply broke the engine, we have some trouble. The content creators couldn't, well, create the content, right? So what about working with two games? I see two ways of doing that. One is to fork your technology, fork your existing game, fork your engine, fork everyone, and simply work on them separately, right? From some time to time, you're going to merge some changes, back then cherry pick something. And the second is to share the technology between the two games that you are working on, or more, right? And you should probably, well, you probably know what we decided to do. We decided to share the technology. And right now, I'd like you to stay away and listen about the repository structure and the architecture that we are using in Techland. So basically, we have a layered architecture where the core engine, game framework, and all our products are stored together with the assets on one big repository. We're using the Helix Perforce that I told you before to separate, to specify only the files, paths that are needed for the products. Like, for example, we have subset of paths from our repository to work on Dying Light 2 or editor, etc. And therefore, we are using one technology, one recent changes to develop all of our products. So the early approach that we used, that we tried to use when we are started to work on those two games, it was like we wanted to use some classic software approach that I was talking about. We wanted to we prepared some streams, some branches for the programmers to work on them, and release those changes on some given schedule. Like, for example, the engine was released monthly, and the game content game technology was released weekly. And the assumption was that only the stable technology is integrated to the game developers, I mean the content creators, through the mainstream, and the game is copied up daily. But it has some disadvantages. For first, there were infrequent feature releases. And right now, I would like to tell you about the difference from our C engine and the engines, commercial ones like the Unreal. In Unreal, you have the blueprints when you script your game. We are scripting the game directly in the C++, which is, well, awesome. We have game programmers who are scripting the game in the C++. But what it means is that the game is data-driven, and the contents depends on the technology. So you can imagine that it was hard to iterate on changes. And you know that in game development, we need to have a fast iteration, the fastest as possible when working on our features. So developers started to pushing their changes directly in the mainstream. And, well, you can imagine that if we wanted to release the engine monthly and we have daily pushes of changes to the mainstream, the integration part started to be a major bottleneck. So we need to improve our workflows. And we did it. We ditched out the dedicated branches for the programmers, and we decided to release both games and the technology daily. So the fast iterations were there. There were small, frequent changes, so the mergers were easy. And the changes were synchronized on a daily basis. And my advice, guys, really keep it simple, because most of the time it's working. So, yeah. This one concludes the workflows part of my talk. So, the CI/CD. Just to show you the scale of the games that I'm talking about, I want to show you the number of unique meshes of Techland game. So, for example, we had the Expand Rally with about 1K unique meshes. Then we released the games of the similar size, like the Call of Juarez 1, 2, 3, and after that, the Dying Light. Dying Light, our third AAA title, with over 10K unique meshes. And after that, Dying Light 2, which kind of doubled that number. And just to show you the scale, our unannounced title that we are still working on is aiming to be at least as big as Dying Light 2. I probably don't need to tell you that with the scale of the games, the complexity of the CI/CD grows, right? So, for example, with an Expand Rally, we simply had a bunch of batch files executed directly on the developer's PC, and that was it. We developed the game on the one platform, it was PC. After that, the Call of Juarez, when we increased the number of platforms by one, so now we are releasing for the PCs and Xboxes. And this is a moment when we introduced the Hudson. Nowadays, it's called the Jenkins. And after that, the Dead Island, when we increased the number of target platforms by one. So now we're releasing for the PCs, Xboxes, and PlayStations. And we decided to transit from the Bash script into Python scripts. I probably don't need to tell you that we inherited a lot of stuff from the Dying Lights. So we inherited like unit testing the game, building the code, building the asset, basically baking the whole game, right? But now the new challenges come. We need to do it, exact same thing, but we need to do it for 2 games stored in one big repository for each available platform, production, prototyping, QA, and even outsource. And what we decided to do is we used some general software approach for the pipeline systems. And to be honest, it turned out great. We created a PyModules library divided into 2 major parts. One was the Jumble, and the second was the cookbook. In the Jumble, we stored all our core functions for the pipelines for the game to be baked, like the code and resources build, packaging, patching, fault handling, everything, even the game automation part. Well, fun fact, when I was working as a QA engineer, this was the main part of the system when I pushed my changes. And second fun thing about the Jumble is that there was a requirement to write some unit tests. And my advice is for you guys, if you have some similar system or the code in general, write the tests. It's really a good idea. And finally, I talked about the fast iteration that are needed, right? So even there, we had to have some place for making a quick and dirty changes, like the storing some glue codes. So the cookbook was the place to do that. It was connected directly to the Jenkins pipelines. I showed you this diagram before. You know that we are storing everything in the one big repository. And now the developers are pushing their changes into different parts of the system. So, for example, what should we do when a developer push the new assets for the unannounced title, for example? Well, we should probably rebuild them and store them for it to be used for later, right? So what should we do when the developer changed the Dying Light 2 code? Well, we should trigger some job for testing it to verify it, and similarly with the editor tools. And what should we do when the programmer changed the core part of our system? Well, we should verify everything that is dependent on that. So how can we react to those changes? I see 2 ways of doing that. One is to use some SCM polling, and the second is to use the hooks of your content management system, versioning system. In our case, is perforce triggers. And we use the polling in all our previous projects, but even then, we've seen that there is some computation overhead when we are working on much smaller repository. So we knew that we need to change the system. And there were the hooks. They were tool independent, which is nice, but there is one caveat. The logic in the hooks should be relatively simple. At least it should execute quickly. So you don't want for your developers to be waiting for the complex logic to be executed each time they push their changes, right? So what we did, we created Django server, Django application, which was connected to the triggers in the way that is as simple as possible. Basically, when the change happened, we made a HTTP call to the Django server, and all the logic for the pipelines were stored there. And since it was a Django application, we have a lot of things for free, like the management, etc. So all the logic is written here. And now we know that when the core part of our system is changed, we know what job on what automation server should be triggered. So finally, our 2 games in one stove approach looks like that. We have an Unleash server, Unleash Django server, which coordinated every automation server. It used the PyModules library for the execution of the functions, and each job was executed on the builders and runner farms managed by our IT department. And this one concludes the CI/CD part of my talk. So, yeah, in the early stages of the development of the two games, well, the faults were there, and they were visible for sure, but they were not untracked. And like you can imagine, the untracked faults like to stack up. So people were simply accustomed to the editor engine crashes in the way that we have a situation when we have the content creators running two instances of the editor, for example, and the second one was there just in case if the first one crashes. So we needed to do something with that, and we better do it automatically. So what we did, we created another Django application, and right now you might think that we are like to solve all of our problems by creating a Django application. You may be quite right, but this one is kind of different. This one has an ability to report all the events from all our systems to the through some integrations like the Slack, the Jira, and email other tools, store them and visualize them in some internal browser. And we call it the chute because, well, all the events from all of our applications went down directly to the chute what happened. So the situation from before, the crashes. How can we catch those crashes? I see two ways of doing that. One is to launch your application with the debugger, and the second is to embed your exception handler directly into your application. While the first doesn't want or work on consoles. I mean, you cannot have one debugger for all of our platforms. The second one work everywhere. Well, it's embedded in your application, right? But the first work every time. It's nothing better than the debugger connected to the application, right? And the second is sometimes enabled to detect the issues related to the memory corruption, like the stack overflow. Sometimes when the stack overflow happened, well, it's gone, yeah. But even then, we decided to use to embed our exception handler in our application, and we managed somehow to solve this problem with the memory corruption. We use the structured exception handler mechanism from the Microsoft, and it basically looks like that. You have the main function of your application, you have the try except statements, and there you know that the crash happened. So we created some library for the chute for the C++ application to be used. And when the crash happened, we use those to send the event to the chute, right? And now the magic happened. For example, when the crash happened, the Slack message was sent immediately to the developers for them to be known, to be informed, to be able to work on this as fast as possible. It was also saved, and it was reported to Jira. And we calculated some hash function for the call stack. So when the crash of similar crash happened, we simply attach it to the already existing Jira and not overblown our system with new Jiras every time. So it was there. It was for the QAs and for the management to, well, manage those crash further. And I would like to show you the dashboards from the chute, from the situation like the pre-release, January 2021. We had like 30 crashes per average, which is, well, not great, not terrible for the game development, right? And after that, the post-release situation, we came down to the 6 crashes per average, which is awesome, and I personally see a lot of improvement in stability of our tools. And I really encourage you to attach your some kind of telemetry to your systems because, well, it works. But the crashes aren't the only soft faults. Aren't the only faults that we are tracking. We are tracking also something called soft faults, and we call them assertions in the code. So the programmer set an assertion in the code, and it is sent down to the chute, like using the same library, same pattern as before, and is ready to be brought on. Like similar situation, like with the crashes, the pre-release, we had like 12.5K on average, let's say. Assertions happened, but, well, this isn't really important. What is important are those two spikes. When such spikes happened, we knew that something bad happened, and we needed to act on that. And similar situation, like post-release, January 2023, well, there are no spikes there. We are still working on that. Oh, by the way, I needed to cover up some names of the game because it is a code name for our unannounced title and it's super secret, so yeah, you know the drill. So, in summary, our new workflows allowed us to synchronize our changes on some daily basis. Our CI/CD enabled us to produce builds to be tested on a daily basis. And the tools like it should allow us to contain the influences that one game made to another. And by the way, the software I was talking about was, well, developed thanks to the European Union project. And right now, I would like to thank you very much, tell you that we as a Techland are hiring. So if you maybe want to join us, you can catch me somewhere in the conference. And, well, that's it. Thank you very much. If you have some questions, now it's a great time to ask them.
I'll check Slido. Okay, no questions on Slido so far. Do you guys have any questions? Just raise your hand. I'll come with mic. Anyone? Okay, so I have one.
Yeah.
You're part of Techland. Techland is still using their own C engine.
Yeah, that's correct.
So do you still see it like viable as a viable way to develop games in like 10, 15 years in the future?
Yes, to be honest, I do. It has a lot of advantages to use your own engine. So I don't know if you want to hear the details, but yes, I see. I see it I see the future of this.
Okay.
Thank you for your presentation. That was a great talk. And in terms of keeping the technical part, it's like pristine, really good IT approach, and it should work fine either way. Even the early approach in smaller projects will work just fine, and it looks impressive how you structurized all the scripts, and this is all great. And I'm wondering, since it's easier with the code, but how do you keep the assets intact? Do you have some filtering when the assets have wrong names, or do you have any clutter in terms of the non-technical parts of the project?
Yes, of course. We have some triggering done. I mean, some validation done before the change even is pushed to the repository. So yeah, we check the names, we check the validity. We have all sets of scripts to validate the assets.
Okay, any other question from the audience? No one? Okay, in that case, thank you so much for your presentation. Thank you so much for your time, guys.
Thank you very much.
And we'll see each other at, no questions at Slido as well. Okay, so we'll see each other at 11:50, I guess. So thank you.